let's just move to the second presentation, which brings us back to the United States. And Brian Freilich from Keller North America will give that presentation. Brian, the floor is yours.
All right, thank you, everyone. Again, Brian Freilich. I'm a senior design engineer for Keller North America, based out of Houston, Texas, doing a lot of work here in the Gulf Coast region. And like we just discussed, sustainability kind of being this new buzzword. In reality, when we look back at a lot of the work that we've done over the past decades, we see how sustainability really fits into the core principles of our business model, whether it be as a design build contractor, as a consultant, as an owner, and realistically within the design build contractor world, these sustainable practices have always been part of what we're doing. How can we be safer? How can we use less, improve speed, achieve more? So these are questions that we commonly ask ourselves, usually within these three realms of being safe, improving on quality, and improving on production. And we always think of these in terms of money, because as we improve upon any one or any grouping of these terms, then typically there's a reduction in cost and improvement in speed. And so the benefit has always been thought of monetarily. And there's a number of ways that we've done that, whether it be through value engineering to develop a better design and help reduce scope, better equipment, improvement to equipment and safety processes, and so things just I won't go through all of these, but there's a number of questions we ask ourselves as we move through opportunities, as we develop projects and move into production, to say, well, if we can be safer, if we can improve on quality, if we can improve on production, there's a monetary benefit to that. But what we found is there's this overarching sustainability concept, because if we're safer, if we're protecting people, if we're protecting the environment, if we're improving quality while still using less materials or using different materials that maybe have a smaller carbon footprint, or as we improve production so that we're not using as much fuel, really what we're finding is that sustainability is just another metric to measure how well we're doing our job, and not necessarily something else that we have to do. It's already kind of ingrained in the culture that we have. And it really is just that metric to show, here's the environmental benefits of what we're doing as we go through this design build process. One of those ways we use value engineering, specifically here in the Gulf Coast, where we start seeing kind of softer compressible soils, or in areas where we have loose, liquefiable granular materials, is the soil mixing method. It's a ground improvement method where we're basically using our tooling to mechanically disaggregate the soil, add this design cementitious binder, and we're going to improve the engineering characteristics of this soil. So whether it's bearing capacity or earth retention or things like that. And the end result here is kind of like this stabilized material. Now, if I saw this in the real world, obviously I'd use my stop work authority. We don't ever have someone walk out onto an unbraced system like that. But just for the view of showing that, we've mixed these columns, you can see that you still see characteristics of the parent soil, but now we've greatly increased the compressive strength, so we can dig around it and have these freestanding columns for observation. The benefit in terms of monetary benefits is that we can take things that might have had to go on deep foundations and move them back to shallow foundations and mat foundations. We can combine soil mixing with other deep foundations to kind of reduce the overall scope. So yes, we're adding another technique to the process, but in reality, we're either reducing the overall scope for the deep foundation scope or the earth retention scope. And so there's that monetary benefit of using less, going a little bit faster, that improves the monetary benefits of the project, which of course the owner and everyone likes to see. But there's also a sustainability impact of that. We're producing less carbon, we're consuming less cement and steel. Concrete and steel obviously are very heavy carbon production. And another benefit, of course, is that we're decreasing our material dependency And as things become scarcer, as things become more expensive, the less we use, the overall benefit to the project. You'll see a lot of contractors around the globe have kind of developed their own proprietary equipment. These are purpose-built tools that we're using, again, to mechanically disaggregate the soil, kind of break it down, get that cement or that binder slurry into the ground, and really get a good mix, a good quality to get the soil cement, the soilcrete well mixed. Here I'll focus on wet mixing methods. And so with wet mixing methods, we're injecting a grout slurry, so a fluid slurry into the ground to help with the soils. And we have a number of solutions and pieces of equipment and grout designs that we can use that are tailored for these site-specific soils and intended use. So there's another kind of layer there of we're using this method. We've got kind of the purpose-built tool that we need specific for that purpose, and then the grout design that is tailored to the site-specific soil. So again, we're really kind of focusing on making sure that we're using the right equipment, that we're using the right design, and we're minimizing the amount of effort that we have to use and the amount of materials that we have to use. And so what I wanted to do here in this presentation is really kind of look at a broad general use of the site-specific quality control program to really not only ensure quality, number one, because we need to make sure that what we're putting in the ground, what we're producing is up to specification, but also how that kind of relates to the sustainability aspects that these new metrics that we're trying to measure ourselves against. And so the first thing to really understand is that as we're injecting this grout slurry in the ground, which is a combination of the binders, water, and maybe some other proprietary materials, we're really creating a chemistry experiment. We're injecting this material in the ground, the cement's going to hydrate, it's going to react with the water, it might react with the soils in the ground. And so we really need to treat each site, each geology as a chemistry experiment. We have to understand how the grout slurry is going to react with the soils. And we really need to be able to kind of modify our designs as we move along through the quality management process to make sure that we get the soilcrete to the right mixability, to make sure that we get the right quality. And here you can see two videos I took. It looks like the video on the left stopped. But when we have a not optimal grout design, you can see the soilcrete that's coming to the surface is very chalky and stiff. It's going to be difficult to mix. It's going to take more energy to mix. It's going to be difficult to sample. Typically, we'll grab some wet grab samples of the material before it cures to put a couple cylinders together for compression testing. The material on the left is going to be difficult to do that with. And so as we optimize our grout design, we'll see that the material looks a little bit more fluid. It's going to be easier to mix. In this particular case, we can go about 40% faster. That's a huge change in production with a small change in grout design. It's also going to be easier to sample. And again, here showing kind of what the material looks like if we don't have the optimal grout design. We're not going to be able to sample that material. We're not going to be able to kind of get a good quality understanding of what we're putting into the ground. And therefore, we're probably going to end up using too much cement. We're probably going to end up using too much time. And so this quality program is imperative to make sure that we've got the right grout design so that we're getting the right quality, we're getting the right production. The first phase of this will typically be a laboratory testing program or a bench scale program. A lot of contractors use different terms to describe what they're doing. But the basis of the program is to go out in the field, collect the soil samples that we need to mix so that we can classify the soils, understand what these materials are, and then also in the laboratory conditions, mix it with different grout designs so we can kind of understand what the mixability is, what happens when we mix these two materials together, and then kind of get an idea of what we think the strength is going to be so that we can better understand when we move into production, when we move all these big pieces of equipment into the field, that we have a good understanding of what that grout design needs to be. So instead of sitting out there and waiting, we can get to production and we can make sure that we're using our time well. When we think about clay soils that are active, right, they react with water. You put water into clay and it wants to suck it up. It wants to do its little chemical reaction and have its process done. And so what we find is that by adding water and cement to that process, it further complicates it a little bit, where we find that in the lab, when we're mixing grout with clay soils, there's a point in time where we have the right amount of water in the grout to get us the quality we want. And it's different for every soil. Here you can see that we've tested 4 different samples and we've prepared the grout at different specific gravities. And so as the specific gravity is lowered, it basically implies that we're adding a little bit more water into the mix. And so what we've seen a lot of times when we mix at the wrong grout design and we get these low strengths, the gut reaction is typically to add more cement. Well, let's keep adding cement until we get the right design strength that we need. And what we're finding is that it's not necessarily the cement or the binder, it's that we haven't found the optimal amount of water to add back into the grout. And so it's much easier for us to add a little bit of water and much more environmentally sustainable to add that little bit of water than it is to start adding more and more and more cement until we finally get what we need. And you can see how that kind of correlates with how the soil creep works. If we're not adding enough water, if the grout's at a real high specific gravity, again, we kind of get this chalky material. It's going to be difficult to mix. It's going to be difficult to sample. So we would expect strengths to be a little bit lower. And then as we get that better mixed material, as we get a little bit more moisture in the ground, you know, it's easier to sample, it's easier to mix, and we get this better quality. And unfortunately, this breaking point of specific gravity or amount of moisture is different for every soil, for every type of geology that we're in. So it's, you know, running these laboratory testing programs is very important, especially when we get to soil zones that are highly variable. And this is a project site we worked on where we were mixing through 3 different soil zones, kind of a leaner clay, a more plastic clay, and then an organic clay. And so what we explored is, okay, well, if we mix each one of these samples with the same grout design, right, you can see that the strength that we get from our laboratory testing is quite a bit different. And so if we think about it in terms of, oh, well, we need to have about 0.8 MPa strength, well, we're going to have to add a bunch more cement to that profile, right? Because the organic material didn't give us the strength we need. When in reality, what we need to do is make sure that we zone out our profile. And we have the equipment and tooling now, which I'll talk about here in a little bit later, that allows us to zone out these profiles so we can target the more problematic zones with a little bit more binder, a little bit more grout. And then in zones where we're getting better performance or performance closer to where we need it to be, we can actually reduce the binder in those zones. So we don't have to just use that single grout design for the entire program. We can very well zone out where we need to be with depth along the profile so that, again, all we're doing is making sure we put the right amount of cement in the ground. See here, it's not moving forward. There we go. So we've run our test program. We're pretty happy with our grout design. We think we understand what the performance is going to be and what the moisture content needs to be to get into the ground. I'm a huge proponent of installing what I call calibration columns. So basically, a calibration column is basically just us kind of confirming what the lab is telling us and making sure we're on the right track before we start grabbing samples for QC testing to make sure that we're conforming to design specifications. Again, the benefit being is that we're out in the field, we're using the real equipment that we're going to mix the soil with, and so we can really see what's coming out of the ground. We can really grab the soil creep, run samples. Here you can see we grab the soil creep core to get a good visual observation with depth. You know, so those visual keys right there are really giving us a lot of information, a lot of qualitative information to say, well, you know, the grout looks good. It's going to be easy to sample. We're hitting the production rates that we think we need to be at. And then we can collect samples for testing and benchmarking. And the other thing we'll do is we'll say, okay, we think we're kind of close to where we need to be on this grout design, on this mixing program. We'll start installing calibration columns at different cement contents, at different specific gravities. So again, we come up with kind of this lab study, this field study to kind of corroborate what we saw in the lab. And so here again, we go out to the lab, we mix at a couple different specific gravities, a couple different binder contents, and we're just trying to calibrate ourselves to make sure that when we go into production, we've got everything set the way it needs to be. We're using the right amount of cement, we're using the right amount of binder. And again, here you can see kind of the radical effect that having the right amount of moisture in the ground will give us, as compared to adding more cement, right? We added more cement on one of the columns, and we don't see a huge improvement in compressive strength of the stabilized material. Really what it was is it was just adjusting that water. So a lot of times what I use these slides for when I'm talking to consultants and owners and kind of showing them our process is that when we see things that might not look like the strengths we want, the gut reaction shouldn't be to throw more material at it, right? We shouldn't be just throw more cement at it, throw more binder at it until we get the strength. We really need to calibrate ourselves very carefully to make sure that we're not wasting resources, wasting time, and wasting money. Now, I've shown two examples here where if we lower the grout specific gravity, i.e. we add more moisture to the ground, we get better performance. Again, every site is different. Every site's a science experiment, almost a different chemistry experiment. We go right down the road and we see the opposite type of performance. So again, here, the more water we add to the system, actually the poorer the performance, because again, it's also based on the water cement ratio that's in the ground. So I'm very adamant on all of our projects that we run these first two phases of a quality program, right? We run the lab testing to really give us an understanding of how the soil is going to react. And then we run these calibration test columns to kind of calibrate ourselves, make sure the grout design is correct, make sure we're getting all the parameters that we need to be at. So there's a lot of variables that get thrown in here, and I'm skipping a lot of stuff about soil geology and plasticity, organic content, deposition, mineralogy, and all that stuff, because it's very difficult to kind of quantify those things in very simple terms. And so, like I say, go out there, run these lab studies, run these calibration columns, and you'll see a very big improvement. So what I really wanted to talk about in this presentation is kind of something that I got to experience firsthand. And that's the benefit of adding real-time data acquisition as part of our ongoing real-time quality control program. So as we move from the calibration columns to the test columns to the production columns, we're going to be running this quality control program as we go along. And so before we had, the computers that could monitor these things for us automatically, a lot of this stuff was done visually. And then there was a lag based on grabbing samples and testing samples at 3 days, 7 days, or 21 days. So there was quite a bit of lag in how we can adjust our quality control program. With the introduction of data acquisition system, this real-time system that monitors all these variables for us, we've seen a huge improvement in not only quality, but a huge way of kind of making our projects more environmentally friendly and a lot more sustainable. So this is kind of what we see, what the driller will see sitting in the drill rig. He understands how fast he's going. He understands how much grout's going into the ground, the mixing energy, all these variables that we try to cue and figure out during the laboratory testing program and the calibration columns. We'll set those and go into production with those so that the rig really kind of helps control itself, right? If it's going too fast, we're not getting enough energy, it knows to slow down. If it's going too slow and it's putting too much energy in it, it knows how to speed up. Putting the right amount of grout in the ground. It basically controls most of the aspects of the soil mixing program outside of the human things that we need to do. And so we went through a project where we started without the data acquisition, and then we added data acquisition later. And it was a very good chance for us to really kind of hone in and figure out what the impact was, not only on quality, but on the sustainability metrics that we use in terms of our quality program. Now, again, I'll say that this was a project that was done years and years and years ago. We've obviously been using data acquisition for quite a while, but I still think this is very relevant data for us to look at. And so what I'm showing here is a cumulative probability distribution curve. I've taken all of the sample strengths that we've gotten from our wet grabs and our cores, of just our wet grabs, and I've kind of plotted them here to say, okay, well, our specification for this particular project wants us to have a certain average value or a 50% value and a certain 90% passing or 10% failing under value. So here you can see arbitrarily it was set at about 130 PSI for this particular project. And you can see that our 10% under or 90% passing was about 220. So we're a little bit higher. We can start adjusting our grout design accordingly based on this quality data. The one thing I want to point out though is our average is about 450, and we have break values that are at about 600 PSI or higher. So you see a huge variation in what we're getting from our quality program, right? We're going out, we're grabbing these wet grab samples, we're curing them, we're waiting 28 days to break them. And we're seeing anywhere from about, 120, 130 all the way up to 600 plus PI, 600 PSI. So it's kind of a huge variation. And so we said, okay, well, we're going to try to calibrate ourselves, do a little bit better. We had our data acquisition system in there. And then we start measuring this purple data. And what we notice right off the bat is that, we've reduced the variability in mixing. The quality is greatly improved. Our average value is about the same, right? We're still in that 400 to 450 PSI. But where we see the huge difference is at this 10%, is at this 90% passing value. So this is the specification that we're trying to meet. 90% of our samples have to be 125 or higher. Here, we're at 360. Well, what does that tell me? Well, based on how we were doing things previously, where we were using kind of visual cues and this lag in strength testing, we're using way too much cement, okay? So the benefit of this data acquisition system, not only is that it gives us this better quality, but it's really going to allow us to start using less and less material and improve our costs and time. So just for this particular project, we were able, just with the inclusion of data acquisition on the project, we dropped our binder content by about 20%. So that was a 20% reduction in cement we were using on this phase of the project. So when we're talking about projects, phases that are using 50,000 tons of cement or higher, a 20% reduction on each one of those phases is astronomical, really. I mean, we're talking about the equivalent of 8 million pounds of burned coal per phase that we're saving in terms of a cement consumption. The benefit for the client, for the owner, is that, oh, well, we don't need as much cement. We'll share that cost savings with you. So they get a cost savings and a sustainability benefit from us kind of improving on our processes and moving forward for our processes. So this was on phase 1 of 4, right? And so we keep improving and improving. And this was the benefit from just one thing that we did, right? So this doesn't include savings for adjusting the grout design once we figure out the mix design, the right specific gravity, kind of improving on our tooling, improving on our equipment. Each one of those adds up quite quickly. And so with this better quality, with this better strength, it really gave us the option to do a number of different things. Excuse me. It gave us an option to do a number of different things on these future phases and on future work. The first one being, of course, adjusting our grout design and reducing binders, right? We're not going to have to use as much cement, so we'll adjust accordingly. That's a cost savings to the owner, and there's an environmental benefit for that as well. The next thing we can do is obviously increase our design limits. We went back to the design team and said 125 is obviously too low. We can achieve greater. So if we were limiting ourselves based on this arbitrary 125, we can increase that to some value. There's a reduction in scope there too. We ended up doing a little bit of that. It was about a 5 to 10% reduction in scope. So in reality, we'll typically do a combination of both to better satisfy specifications. So this is really allowing us to do a lot of things in terms of value engineering, in terms of quality management, to make sure that we're not using too much cement, to make sure we're not using too many materials, to increase our production, and again, to reduce our scope through value engineering design. The last piece I wanted to talk about is don't forget what you've learned. So we spent decades trying to improve upon our quality programs to make sure we're using as little material as possible to get the best benefit, to get the best bang for our buck. And one of the things that I've seen happen time after time with different project teams on different projects all across the globe is that we spend a lot of time and effort developing these grout designs, modifying our tooling, modifying all these different aspects to improve our safety, to improve our quality or improve our production. And then at the end of the project, that the project team kind of goes on to the next project. Maybe we take some lessons learned or whatnot, but we've been as an industry somewhat not as great as really documenting the data that we've seen and using that as we move forward. And so what I always do is at these projects where we've had huge changes in grout design, or we've had great improvements in material that either gives us a higher strength or it gives us a better quality or a better production rate, I always have these little graphs I put together. So I'm showing 3 here that we put in a paper that I think will be presented in New Orleans next year, where we looked at a bunch of grout designs for similar soils, for similar grout designs, and really kind of understand the impact of of soil, mineralogy, of soil characteristics on what the final soil cement behavior is going to be. And we saw that there's a number of different variables that really can impact what that grout design needs to be. And so when we have this type of data put together and summarized for us to use with our project teams, we're already a step ahead when we move into the laboratory program, when we move into the calibration column program. And again, we're taking that 10 to 30% benefit in terms of either reduced binder or reduced scope or whatever it is, and we're moving it on to the next project where we'll further refine on that number. What are the benefits that we can do now that we've already learned these other things? And so I always encourage everybody, you know, when you're on a project, whether it be soil mixing or any type of project where you're doing value engineering, where you're learning something, making it a little bit better, that we need to do these documentations to show it, because it's a benefit not only to the industry, it's a benefit to every aspect of the project moving forward. And so just, you know, just to summarize kind of the talking points, I think, you know, really, I didn't talk explicitly about sustainability, but we mention it a lot because it's just ingrained in everything we do. And these quality control methods that we put in place to make sure that we're getting, you know, we're meeting the project specifications, really also help us achieve these safety, quality, production, sustainability goals. You know, and like Niall said earlier, when we see better quality, when we see improved safety, when we see any improvement in safety, quality, or production, there's a lower cost, and we're providing a more environmentally sustainable solution. So when we talk about providing these sustainable solutions, that doesn't mean the costs are going to go up. In fact, most of the time, every time I've been involved with a project where we're looking at a sustainable solution, the costs have gone down. So there's a cost benefit to that. And then just quickly go through this simple multi-phase quality program. At each phase of that quality program, we identified ways to increase strength, to increase mixability, and therefore reduce cost, reduce our environmental impact. And so again, the last three kind of points are just general talking points to the geotechnical community in general. But we need to make sure that project specifications are written so that we can allow these real-time adjustments to our construction needs. Because if we are using too much, if we are doing too much, we need to be able to adjust ourselves and reduce our scope, reduce our usage. And I've seen a lot of project specifications where it explicitly excludes us from doing any changes. Right, so we know we're doing too much, and we need to be able to move that into our project specifications to say, look, if we've got these real-time processes put in place that are showing quality is exceeded, we need to be able to make these adjustments. You know, data acquisition kind of being the real big one. I did forget to mention that with the data acquisition system, we get a report for every element that we solve that shows the energy that we put in the ground, that shows that we put the right binder content in there, and then we correlate that with the strengths that we're getting from our wet grab strengths and whatnot. And it really kind of lends itself to, you know, making those real-time adjustments and showing where we're getting. And as always, once a project is complete, you know, lessons learned and results should always be compiled to assist with future work. Thank you very much. Appreciate it.
Thanks, Brian. Thanks for a very interesting overview of what you can do and then how you approach a project and looking at a chemistry test when you go to a site. Before we go to the third presentation, what I would like to talk a little bit more with you about is that last item that you mentioned, lessons learned, and tied it in with one of the first slides that Neil used earlier in his presentation. Keller is a large organization, just like AECOM, presence worldwide. You're doing this kind of work all around the world. How do you approach the lessons learned, that it's not only within your group or within North America, but lessons learned and sharing that information around the world? Can you say a little bit more about that?
Sure. And Keller does a number of different things internally. Like you said, we're a large company. We're on 7 continents as well. We have 2 ways that we share good lessons learned and best practices. And one of those is through what we call internal product teams, basically groups of experts from around the globe that meet and share these best practices. So there's a soil mixing product team that I'm a member of where we get together. And as we learn new things, as we gather new data, this group kind of compiles it together and then shares it with the rest of the soil mixing practitioners throughout the world. And so it's a very quick way for us to get involved with projects during the planning stage to make sure those best practices and lessons learned are in there. And just like with any company, and I've worked with a number of consultants and other contractors who do internal webinars and internal trainings, where we share that information with the global community. And so these are online webinars similar to what we're doing right now, where we go through these best practices and lessons learned, and we have the people who did the design, who are managing the production and the quality, who are improving upon the safety to give these webinars internally, not only within Keller, but we've also done it with the outside consultants and contractors and owners that we work with to really show that we're serious about that improvement. Because you know, like I said, when we benefit, the benefit of doing this is as we improve upon safety, quality, and production, you know, there's a financial benefit to it, and then there's a sustainable benefit to it. So educating ourselves internally, educating those that we work with is very important for us, and that's kind of the 2 ways that we do that.
Thank you. And then for